Welcome back, students. Today we explore a set of special functions that appear frequently in JEE graph questions, especially the Signum function, which students often misunderstand. By the end of this lecture, these graphs will feel effortless. Definition: SGN equals 1, x greater than 0, 0, x equals 0, minus 1, x less than 0. Intuition tells you the sign of a number, completely ignores magnitude. Examples: SGN equals 1, SGN equals minus 1, SGN equals 0. Graph looks like line at y equals 1, line at y equals minus 1, a single point at. Discontinuity: jump at x equals 0. Domain: all real numbers. Range: 1, 0, 1. Very important identity: SGN equals x/x. X is not equal to 0 and x equals x SGN. Useful in JEE Advanced algebraic manipulations. For y equals SGN, the jump shifts to x equals a. For y equals SGN, the graph becomes 1 where f greater than 0, 0 where f equals 0, and minus 1 where f less than 0. This converts any function into a +/0/ classifier. A step function remains constant in regions and jumps at boundaries. Examples include the greatest integer function, the Signum function, and piecewise constant functions. JEE may give a function like f equals 2, x minus 3, minus 1, minus 3 less than or equal to x less than 1, 4, x greater than or equal to 1, and ask discontinuities, range, limits, etc. The identity function f equals x is a straight line through the origin, with domain equals range equals. The constant function f equals c is a horizontal line, often used in modulus and signum composites. Polynomial functions are always continuous everywhere, with no jumps, holes, or asymptotes, and their graphs are smooth and differentiable. The reciprocal function f equals 1/x has a vertical asymptote at x equals 0, a horizontal asymptote y equals 0, two symmetric branches, and is an odd function. JEE graph transformations often involve shifting this graph. The greatest integer function is important as a step function example. The Dirichlet function f equals 1, x is an element of Q. 0, x is not an element of Q is discontinuous at every real number, with a range of 0, 1. It helps understand dense sets and discontinuity. Signum function and step functions do not satisfy the intermediate value property. Between -1 and +1, SGN never takes any value except at x equals 0, which is still 0. This is useful to eliminate options in advanced graph questions. Q1. Solve SGN equals 1. This means x, 3 greater than 0, so x greater than 3. Q2. Solve SGN equals -1. This means x superscript 2, 9 less than 0, so -3, x less than 3. Q3. Evaluate SGN. Cases: x, 2 greater than 0x, -2, or x, 2 value equals 1. x, 2 is equal to 0x equals plus or -2 value equals 0. x, 2 less than 0 -2, x less than 2 value equals -1. Question solve SGN equals 1. Both must have the same sign. SGN equals 1 for x greater than 2, and SGN equals 1 for x less than 3. The common region is 2x less than 3. Question sketch graph of y equals SGN. It's one where sin x greater than 0, -1 where sin x less than 0, and 0 at multiples of pi. This creates rectangular pulses and is a common advanced graph question. Students, solve SGN equals -1. Sketch graph of y equals SGN. For f equals SGN, find intervals where f equals 1. Identify discontinuities in f equals SGN plus x. Evaluate SGN.